Section 1.2 is all about properties of functions. So in this section, we're going to look at both functions that are in context and out of context. When I say in context, I mean that there's a story around the problem. So looking at this first example, the average monthly temperature in Anchorage, Alaska can be modeled by a function C of T. That's how we say this part, C of T, where C is measured in degrees Celsius and T is measured in months since January. A table and graph for the function for T in between 0 and 11 is shown below. Use the graph to answer the following questions. So before we just jump into these problems, let's kind of break this down and familiarize ourselves with what this graph and this table are actually talking about. I see T and I see C on my table. On my graph, I see month since January, and I see temperature in degrees Celsius. So I know that the T's are the month since January, and the C's are the temperatures in Celsius. When it says a table and graph of the function for T in between 0 and 11, that's just saying that my T values on the graph go between 0 and 11. So when I'm talking about months since January, this 0 month is 0 months since January, meaning it would be January. 1 month since January would be February. 2 months since January would be March, and so on. So now let's look at the questions. Part A says, on what intervals of time is the average temperature increasing? When we see the word interval, that means like a time period. So on which time period is the temperature increasing, or when is the temperature going up? When we read a graph, we always read from left to right. So as my eyes start over here on the left, I see that my eyes go up, 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 then down, 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 down. So I'm trying to decide when is the graph going up. And I can see that it starts here and ends here. Since I'm looking for an interval of time, I want to use the months since January. So from month 0 to month 6. So I could even write that in words from month 0 to month 6. My next question is, on what intervals of time, so same thing, we're looking at the months, is the average temperature negative? So when I think about a negative temperature, I know that means below 0. So when I look at my graph, I'm looking to see if this is temperature 0, when is my graph below 0? And that actually happens at 2 different spots here. My first times that the temperature is negative starts here and ends here. So it starts from month 0 to month, this month is 3. And it's also negative from here to here. So, and 9 to 11. Now, as I'm writing this, I notice that there's a lot of words there, and I will be honest, mathematicians want things to be as concise as possible, and they want to be able to communicate clearly. So this is a totally acceptable way to write it. However, instead of writing, for example, on part A, from month 0 to month 6, the faster way to write it is parentheses 0, 6. Same thing on part B. If I wanted to, instead of writing from month 0 to month 3, I could just write parentheses 0, 3, and from month 9 to 11, parentheses 9, 11, close parentheses. For all of these intervals, we're just using these parentheses. So let's try that as we continue. But until then, we're now asked a different question. What is the average rate at which the temperature changes between January and May? If you took Algebra 1 here, you probably remember talking about average rate of change, which is really another word for slope. When we try to calculate average rate of change, we want the change in y over the change in x. To calculate that, our nice little formula to remember is y2 minus y1 over x2 minus x1. In average rate of change problems, I am always going to give you the x values. So when I look at this, I know that January is actually month 0, and May is actually month 4. Now my job is to look for the y values that go with the x values. So if I look up at my graph, when x is 0, the y value is negative 10. When x is 4, the y value is somewhere in between 10 and 5, but I can look at my table and see that when x is 4, y is 8. So I'm going to subtract 8 there. If I do that calculation, negative 10 minus 8 is negative 18, over 0 minus 4 is negative 4. And when I actually do that division, 18 divided by 4, go ahead and get your calculator out if you need it, is positive 4.5. So now I have to ask myself what this actually means. Something is changing when I'm talking about the average rate of change in the temperature. So I would say something like, on average, between January and May, the temperature increased by 4.5 degrees Celsius each month. So when I look at that, if I look between January and May on my graph, it doesn't change exactly 4.5 degrees Celsius each month, but if we average out all of the different months in between, we can estimate that it goes up by 4.5 degrees Celsius every month. Moving on, I want to evaluate C of 8. If I look back up at the top of my problem, I see that this function is modeled by C of t. So if this whole thing is C of t, do you notice how this t is now an 8? When I look at my units of measure, I remember that the t is the times. So when I ask for C of 8, I'm asking at month 8, what is the temperature? So maybe I look at my table this time. When T is 8, the temperature equals 9. In a sentence, I might write, let's change that instead of at 8 months. Let's say 8 months after January, the temperature is 9 degrees Celsius. Part E, estimate the values of t for which C of t equals 5. So if we use our same kind of thinking that we had in Part D, now I know that the temperature is 5 degrees, and I want to know at what month that happened. So I can look at this a couple of different ways. Let me erase some of my circles here. If I look at my table, I'm looking in the degrees Celsius for the number 5 degrees. And unfortunately, that does not happen on my table at all. So now I go to my graph. 5 degrees on the y-axis happens here, and I'm looking straight across my graph to see what months that would happen in. So I see it happening once, twice. So I would estimate that T is maybe around 3.5 for this first point, and maybe around 8.5 for the second point. I'm not going to be super picky if you have to estimate, as long as you're clearly in the ballpark. All right, let's keep looking on what intervals of time, so back to those intervals, is the average temperature decreasing? Decrease means going down. So if I look at my graph, I'll change colors here. If I look at my graph from left to right, my eyes go up, 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 then down, 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 down. So it starts going down or decreasing here, and it ends here. So it starts at month 6 and ends at month 11. And we're going to do our interval notation and just say parentheses 6, comma 11. Part G, what is the maximum average monthly temperature in Anchorage and when does it occur? So we're looking for the maximum monthly temperature, or the hottest, and when that happens. On our graph, we can see that the hottest monthly average temperature happens right up here at the top. So when I read my graph, I can see that that point is at 15 degrees Celsius, and that happens 6 months after January. So I would write a sentence, 15 degrees Celsius, 6 months after January. Part H, on what intervals of time is the average temperature positive but decreasing? So I'm looking for a very specific interval here. When is the temperature above 0 but also going down? So again, I'm going to scroll back up to my graph. If it's above 0, I'm only looking at this top part of the graph. But I'm also looking for when it's decreasing. So as I read from left to right, again, my eyes go up, 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 then down, down, down. So I'm only looking from here to here at my graph. So from month 6 to month 9. Part I, evaluate C of 2. Just like we did up above, this 2 is the time, and I'm looking for the temperature. So if I look at my table, when T is 2, the temperature is -4. And lastly, estimate the values of T when C of T equals 10. This is my temperature, and so now I have to figure out the little t for time. So if I go to my graph, which I'll erase all my squiggles, if I look at 10 degrees for the temperature and I go all the way over, that happens at 2 different times, once here and once here. So we can maybe call that 4.5 and 7.5.